Hey geometry kids. So I just want to go through, I'm going to talk through the proofs that were on the homework that was due today. So for the first one, we know that angle 1 is congruent to angle 2. We also know that angle 5 is congruent to angle 6. So we're going to be able to use that information along with the fact that PQ is, actually I think this might be an O. We'll call it an O. I think it was probably a Q that got cut off, but I'm going to call that O. So that PO is congruent to PO. So that's going to get us triangle PRO congruent to triangle PSO. And then therefore all of their corresponding parts will be congruent. So I will then be able to say that PR is congruent to PS. And I'll label this point right here, we'll call this T. And that PT is congruent to PT. And then that'll allow us to get this triangle PRT congruent to triangle PST. And then we can get angle 3 congruent to angle 4 by corresponding parts. Actually, there's an easier way that I just realized. So that's one way. So you could actually do that. That'll actually take longer. But I just realized once we get PS congruent to PR, then we have this triangle right here, triangle SPR, is a triangle with sides that are congruent. So the angles across from them have to be congruent. So I'm going to write that up, and if you didn't make much progress on that, you can go ahead and try to write that up as well. But I'm going to write that up, and I'll be right back. So here's what that looks like written up. And again, as I mentioned early in my going through my plan for this, it's not unusual, by the way, to miss what I missed originally, that this right here is you can prove that this is an isosceles triangle essentially, and then you get the angles across from them. And that's sometimes hard to see when you've got the triangle split up like that. So sometimes you kind of have to try to look at the bigger picture. But if you had done it the way I had originally described by labeling this point and proving these triangles congruent, that's absolutely fine. It'll just take you more steps, that's all. All right, so let's take a look at question 2. So for this one, they've given you expressions for the lengths of two sides of the triangle, and then they've asked you to find all possible values for the length of AB. I probably could have worded this a little bit better because you're not actually finding numbers. You're going to actually find the expressions that limit the lengths of AB. And some of them will actually work out to be numbers, and some of them will be expressions that have either M or F in them. So over here, I know that AB has to be between the sum and difference of AC and BC. So the easier one to do is add these together. So I know that AB has to be less than what I get when I add M plus 2 to M minus 1. So when I combine the M's, I'm going to get 2M, and then 2 minus 1 is going to be plus 1. And then on the lower end, I have to subtract these two. Now you want to make sure that you subtract them in the order that works, because you want to make sure that you're subtracting the smaller one from the larger one. And I know that M plus 2 is going to be bigger than M minus 1. So if I start with something and add 2, that's going to be bigger than if I start with that same thing and subtract 1. So over here, I'm going to do M plus 2 minus M minus 1. And now I just made a mistake that's a very, very common mistake. And that is that I didn't subtract this entire length. I subtracted the M, but I added the minus 1. So you want to make sure that when you're subtracting something that has more than one term in it, and remember terms are separate. So now we're going to need to distribute this negative sign. So this is going to become M minus M. So these are actually going to just go ahead and cancel. So you're going to do M minus M. And then we have 2 minus a negative 1 is really 2 plus 1. So this side's just going to become 3. So these are the constraints on the length of AB. Notice I don't have the segment symbol above AB because I'm talking about the length of it. So I know that the length of AB has to be bigger than 3 and less than whatever 2M plus 1 is. And then it's the same idea for part B. I'm going to add these together first because, again, that's just the easier one. So if I add them together, I'm going to have 5 plus 5, and then negative F plus F is just going to be 0. So this upper bound is just going to be 10. And then the lower bound, notice you're told here that F is a positive number. That matters because otherwise you can't determine which one of these expressions is bigger. So knowing that F is a positive number means that this one is going to be bigger than this one. So if I take 5 and add a positive number to it, that's going to be bigger than if I take 5 and subtract a positive number. So I know that BC, 5 plus F, is the larger one, so I need to subtract 5 minus F. And the same thing happens here. I want to make sure that I'm subtracting both of those terms. So I'm going to have 5 minus 5, which is just going to cancel. So I'm going to have, those are going to cancel. And then these almost look like they're going to cancel too, but be careful because this is really F minus a negative F. So this is really going to be F plus F. So our lower bound is going to be 2F. So AB, the length of AB has to be between 2F and 10. So for question 3, we're asked to prove that the length of AC is greater than the length of BC. So I want to prove that the length of this right here is greater than the length of this. So what this is going to require, this means that I need to show that angle 2 is greater than angle A. So in order for the side, if this side is going to be bigger than this side, then that means that this angle has to be bigger than this angle. So we're given that the measure of angle 1, so we know that angle 1 is bigger than angle A. And we know that angle 1 and angle 2 are congruent because vertical angles are always congruent. So then we can conclude then, if angle 1 is bigger than angle A, and angle 2 is the same as angle 1, angle 2 has to be bigger than angle A. And that's going to be that substitution property. And then from there, I've proven that angle 2 is greater than angle A, and then I can conclude this. So I'm going to go ahead and write that up, and then I'll be right back. So this is what that proof would look like. A couple things worth noting. Here, I'm actually saying it's the measure of angle 2 is equal to the measure of angle 1, rather than saying the angles are congruent. So my reason's I'm going to modify my reason a little bit, and instead of saying vertical angles are congruent, I'm going to say that vertical angles are equal. So because we're talking about the actual measure of the angle, we're going to say equal. If we were just talking about the actual angle, we would say congruent. So make sure that this is consistent with this. And then this is the first time we've seen this reason pop up in a proof. These don't come up very often, but you should still have them in your theorems and definition section. So because I have this angle greater than this angle, the side across from this angle is going to be greater than this side across from this angle. And this is the reason that I will give for that. So then for number 4, this is going to be somewhat similar, right? Because we want to prove that angle 2 is greater than angle A, that the measure of angle 2 is greater than the measure of angle A. So now what this means is that I need that AC is greater than BC. So it's sort of the reverse from what we had up here. So let's think about how we might get at this. So I know you're given that AC is greater than AB, and we're also given that angle C is greater than angle A. So if angle C, the measure of angle C is greater than the measure of angle A, that must mean that the length of AB has to be greater than the length of BC. And now we can use a transitive property in there and get to this statement, which will allow us to get to this statement. So again, I'm going to write that up, and I will be right back. All right, so here's what that proof looks like. So we've got our given. And again, I put this in the order that it makes most sense. So I did not list all the givens first. So I'm going to use this given to conclude that the length of AB is greater than the length of BC. And then again, the reason here is going to be the same thing up here. I've got the longer side is across from that larger angle. And then my other given, and then I'm going to put these two together using transitive property to conclude this. So here's how I put that together. Notice that both of these have AB in them. So I can kind of link these together and say I've got that AB is greater than BC. That's in step 2. And then in step 3, I also know that AC is greater than AB. And so the transitive property says I can kind of cut out that middleman there and just go directly from here to here and say that AC is greater than BC. So up till now, we've only seen the transitive property with congruence, but it also works with inequalities as well. If I know that AC is greater than AB and AB is greater than BC, then it only stands to reason that AC has to be greater than BC. So I'm getting this by transitive property. And then once I know that one side is longer than another, I know the angles across from them have to follow that same order in terms of size. So that allows me to say that the measure of angle 2 is greater than the measure of angle A. And notice here I've swapped these around here because here I concluded that I started with the longer side and concluded the larger angle. So here I'm saying that the larger angle is opposite the longer side. Whereas up here I started with the measures of the angles and concluded the lengths of the sides. So I just swapped these around, so just make note of that. Alright, so for this one, what we're looking for down here is we're looking to put the side lengths in order, essentially from largest to smallest. So my strategy here is I'm just going to start with the triangle on the left and list what I know about those sides. I'm going to list the order of those sides. So in the left-hand triangle, because I want them largest to smallest, I'm going to find the largest side of the left-hand triangle, triangle EFH. So the biggest angle is here, so the longest side over here is EF. So I know that EF is bigger than, the next one is going to be EH, is bigger than FH. So I know that from the left-hand triangle. I think I probably said right hand that entire time, but I hope you understand I was pointing to that triangle EFH. And then on the right-hand side, I'm going to do the same thing. I'm going to find the largest side, which is FH. And I know that FH is bigger than HG. And I know that's bigger than FG. So I'm just really looking at the angles and taking the sides across from them, starting with the largest angle. So the largest angle, take the side across from that. The next largest angle, take the side across from that. The smallest angle, take the side across from that. And now you'll notice these actually link together very, very nicely. So I know that, again, it's basically that transitive property. I know that EF is bigger than EH, is bigger than FH, but FH is bigger than HG, which is bigger than FG. So there's my order. EF, EH, FH, HG, and FG. All right, and then the last one. So here we're given some information about which angles are larger than others. So I know that angle A is larger than angle C. So I can use this information to conclude this. So given that angle, all right, so for this last question, I'm going to take you entirely through my thought process here. Because I don't actually know the answer for this. I'm going to have to work it out. And I want you to kind of see what my process is when I approach a problem like this. So we want to put these angles in order here. And what we're given are a bunch of side lengths. So my first thought is I'm going to look at what angles I need to work with. So I know I've got angle A and angle C. Those are both angles in the big triangle there. So I can use side lengths of the big triangle to figure out how these relate to one another. Triangle ADC is also in that big triangle, so I can use this big triangle to get all three of these in order. And then triangle BDC and angle BDC and angle DBC are both angles in this triangle right here. So I can use the sides of this triangle to get these in order, and then hopefully something nice will happen. But let's just see. So I know here that the largest side of triangle, and I'm just going to draw it separate here, that this is 13, 15, and 14. And this is A, D, C. So this is going to allow me to get these three angles in order. So again, I want the largest one, so I'm just going to put them in order largest to smallest. So the largest side of this triangle is 15. So that means the largest angle. That means that the measure of angle A is going to be the largest angle in that triangle. And then the next largest angle is going to be that angle ADC next. And then that's bigger than the measure of angle C. So that gets me these three in order. And then I want to look at this triangle right here. That's going to allow me to get these in order. So this is 12 and 15 and 9. So we've got D, B, C. So now angle BDC, that's across from the smallest side. So I know that the measure of angle BDC, that's going to be the smallest one. And the measure of angle DBC. That's actually going to be the largest one in that side, in that triangle. All right, so now we need to somehow tie these things together. And it's not readily apparent how that's going to happen. So we're going to have to do a little bit more work here to figure this out. All right, so now I got to figure out some way to put these together. Now you'll also notice that there's an angle C in this triangle and an angle C in this triangle. There are the same angle C's in these triangles. Another strategy that I will sometimes use when I'm trying to do something like this is instead of calling them angle ADC and angle DBC and whatnot, you could number them if you want. Sometimes that gets a little confusing when you're doing inequalities or equations because then you've got numbers in here that may not necessarily match. So for example, you might have something like angle 1 is greater than angle 2. So sometimes I'll just label them with symbols. So I'm just going to label the angles that we're working with here. That's angle ADC. And then angle DBC, I'll make this a little star maybe. It's kind of hard to tell those apart, isn't it? And then angle BDC. So I'm going to just use maybe a little dot right there. So I'm going to change this one so that you can tell the difference between these two symbols. So I'm going to put, I don't know, a little square there. And so now I'm going to replace those. And this just helps me more easily sort of keep track of things because it's harder for my brain to process things when they're written out as a three-letter designation for an angle measure. So now what I'm going to do instead, I'm going to just rewrite these. So again, like I said before, you're watching me do this and work through this problem in real time. This is a very challenging problem. So you can see it's not coming quickly and readily to me. So, but I want you to see what it's like to really logically work through a problem and sort of persist through it. So I know that I'm going to have, and I'm going to drop the measure of angle A's and things like that. So I'm just going to simplify it a little bit and say this. And then down here, I'm going to include the symbols here, but I'm also include the C because that's going to help me tie these two things together. So in this triangle, I know that the star is the biggest side, and then that's bigger than C is bigger than this little dot that I've drawn there. So now that C is the thing that's my overlap right there. That's going to be the thing that's going to tie these things together. So somehow I have to figure out how to get these in order. And it's not as straightforward as it was up here because these tied together very nicely. These are not tying together quite as nicely. So we've got to do a little bit more work to do here. So this is angle, I'm going to put these symbols over here as well. So that's this one and this is our star. So I already know that angle BDC is going to go here. So I know that. So that's my angle BDC. So really it's a question of how these two things relate to one another. So I know that this is the star angle, and this is that one that I've labeled with a square. So I need to figure out how these relate to one another. This certainly looks like it's a right angle here. We haven't talked about this, but the only way I know of to verify whether or not this is a right angle is to look and see, does the Pythagorean theorem hold true? So what we want to check is, the question is, if I do 12 squared plus 9 squared, is that equal to 15 squared? Because if it is, then that means that Pythagorean theorem, that a squared plus b squared equals c squared thing you may know it as, if that's true, then this is a right angle. And that will help us because then these angles will be the same. So this is 225, and the left-hand side is also going to be 225. So this is in fact a right angle, which makes this a right angle. So that's going to help us as well, because now I know in this little triangle right here, I know that this is the longest, or this is the largest angle, and I know that this angle is smaller than this angle. So that's going to help us as well. And that helps us because now it allows me to relate angle A to this angle that I put a star on, which is this one right here. So I now know in this little triangle here on the left that this star right here is greater than A. So that allows me to do this. So here they are right there. They're coded, but that's them. So that was a heck of a process. But again, the key here is just kind of keep working at it. What my strategy is, I'm going to just start writing down everything that I know and then hope that things kind of come together. So the only piece really here that maybe was a little bit unfair was that you would need to remember that fact, I think. And maybe one of you guys found a different way to go about this. And if so, that'd be great to hear about in class. So now it's just a matter of putting these in order, right? So I've got angle D, the measure of angle DBC is the largest one, then the measure of angle A, then the measure of angle ADC, then the measure of angle C, and then lastly the measure of angle BDC. So that was quite a challenging problem. Hopefully you made some progress with it at least. Even if you didn't end up with that final step, I hope that you were able to at least get some of these pieces there. But again, the key here is to just write down things that you know and hopefully something good happens. But if you just find yourself staring at it and then nothing comes to you by staring at it and then just giving up, you want to start writing things down. I think you'll be surprised at what will happen sometimes and often if you, instead of envisioning things in your mind, you actually put those things on paper where you can actually literally see them rather than envisioning them in your mind. So again, if you made any progress on that question, great job.